The cave mouth is a threshold. One step and daylight dies behind us. In here, the world is rewritten by darkness. No sunrise, no seasons, no plants, no green, just rock, water, and time. And yet life persists. Small shapes slip through black pools. Pale bodies drift over stone. Some of them have no eyes at all, only smooth skin where sockets should be. It feels unsettling, like nature has erased a feature we depend on. But this isn't decay, it's adaptation. In caves, vision is expensive. Eyes cost energy to build. They cost energy to maintain. And in the dark, they return almost nothing. So evolution starts making ruthless trades. Over generations, eyes shrink, pigment fades, and other senses begin to swell into the space that sight once occupied. It's not just survival. It's a different way of knowing the world. Listen closely. In the black, every ripple matters. Every chemical trace is a message. Every vibration is a map. We're about to meet animals that don't merely live without light. They've turned darkness into an advantage. And the deeper we go, the stranger the bargain becomes. A single pollutant can spread through underground water like a slow, invisible tide. A new road can change a cave's airflow. Tourist lights can grow algae on walls that evolved to stay bare. And a species that took millennia to adapt can vanish in a season. In the dark, extinction is silent. Yet caves also hold a promise. They are natural laboratories, places where evolution runs experiments we can still read. By studying how eyes are lost, we learn how organs develop, how brains rewire, how genes can shape multiple traits at once. And caves ask us to rethink what a sense is. Is vision only light? Or is it information gathered through any channel nature can build? In these animals, extra senses aren't extras at all. They're the main thread holding life to the world. We leave the cave and daylight returns like a flood. Our eyes adjust within minutes. The surface feels loud, bright, overwhelming. But somewhere beneath our feet, in water that has never seen the sun, a blind fish turns toward a ripple and reads the universe through its skin. What other ways of sensing are possible? Not in imagination, but in biology, waiting in the dark for us to notice. There's another reason caves create such strange creatures. Isolation. A cave is a locked room for evolution. A population enters by flood, by accident, by a collapsing river, and then the door closes. Cut off from the outside, small groups drift genetically. Random changes can spread. Rare traits can become common. And because caves are stable, temperature steady, light absent, predators scarce, natural selection can focus on a narrow set of problems. Find food, find mates, conserve energy. Over thousands of generations, cave populations diverge from their surface relatives until they become something new. Sometimes we can see the transition in real time. In certain fish, individuals vary. Some have small eyes, some smaller, some nearly none. Their brains show shifts too. Regions for vision shrink, while regions for smell and touch expand. It's a reminder that evolution isn't a ladder. It's a budget. Spend here, save there. Trade what you can't use for what you can't live without. But the most haunting part is this. Cave animals aren't primitive. They're specialized, finely engineered for a world that almost no one visits. And that means their survival is fragile, because the cave is sealed until we open it. In a few dark waters, some fish produce weak electric fields. Not lightning, not shock, a gentle halo of current around the body. In the open, it's subtle. In caves, it can become vision by other means. As the fish swims, objects distort that electric field. The fish reads those distortions through receptors in its skin. A rock edge, a narrow crevice, a moving prey item, all revealed without a single photon. It's called active electroreception, and it's as close as nature gets to building sight from scratch. But even without electricity, caves push senses into extremes. Some cave insects have longer antennae, stretching their reach into the dark. Some crustaceans grow delicate hairs that detect the faintest currents. Some amphibians become so pale they seem carved from wax, because pigment offers no advantage where sunlight never comes. And the changes aren't only physical. Behavior shifts too. In darkness, speed can be wasteful. Ambush becomes strategy. Patience becomes power. Animals learn the landscape by memory and scent, tracking familiar routes through labyrinths of stone. Here, the cave is not just a habitat. It's an architect. It removes the obvious. It rewards the subtle. And it asks a quiet question. What would you become if the most important sense in your world was suddenly irrelevant? In the still water of a subterranean pool, a blind fish turns. It doesn't see you, but it knows you are there. Along its body runs a line of tiny sensors. The lateral line, a system that detects pressure changes and water movement. In open rivers, it helps fish school and avoid predators. In caves, it can become a superpower. Some cavefish grow more sensory organs along this line. More receptors, more resolution. A drifting pebble, a struggling insect, a fin flick in the dark. All of it becomes audible to the skin. And then there's touch. Whisker-like appendages, elongated fins, sensitive snouts that probe the rock like fingertips. Even taste changes. In darkness, chemicals are clues. The faint bitterness of decay. The metallic trace of groundwater. The signature of another animal passing hours ago. These animals navigate by a mosaic of hints, each one too subtle for us to notice. But together, they form a world. It's tempting to call it extra senses, as if they've gained a new organ, a new magic. But it's often a deep refinement of abilities we already have, turned up, tuned in, and made essential. And still, caves offer another twist. Sometimes the sense that expands isn't touch or taste. Sometimes it's electricity. To understand why eyes vanish, we have to measure the cave's economy. Food is rare. A dead insect, a root thread, a flood-borne leaf. These are feasts. In such scarcity, wasting energy can be fatal. An eye is a living organ, delicate tissue, constant repair, constant upkeep. If it doesn't help you find food or mates, it becomes a cost without a benefit. Natural selection doesn't choose blindness. It simply rewards anything that saves energy and still works. A fish born with slightly smaller eyes may grow faster. A salamander with reduced pigment may divert resources to reproduction. Over time, those tiny advantages compound and sight fades away. But something else happens at the same time. As eyes diminish, the brain doesn't sit idle. Nervous systems are flexible. If you stop feeding visual information, other channels could take over. Touch becomes sharper. Smell becomes richer. The body begins to read water, air, and stone like text. In some species, genes that build eyes also influence other traits. When the pressure to maintain vision disappears, those genes can shift, and the cave begins to sculpt new anatomy from old instructions. What looks like loss from the outside is often a reallocation inside. And in the dark, that reallocation can become something extraordinary. Because in caves, the senses don't just compensate. They evolve beyond what light ever required.